Hello there. Today we have Pre-Calc Lesson 68, the locus definition of a parabola, translated parabolas, applications, and derivation. So, let's first talk about parabolas, okay? We typically know the parabola is y equals x squared. That's our standard parabola, okay? Now, narrow and wide parabolas. This is our standard y equals x squared graph, goes through 1, 1. If we multiply the x squared by 3, it actually becomes more elongated. So we have y equals 3x squared. So now when we plug in 1 as our input, our output becomes 3. And if we have y equals 1/3 x, it elongates it in the width. It makes it wider. So we have y equals 1/3 x squared. And this is important because we're going to be talking about different ways to get the equations of parabolas. Now, let's look at reflected parabolas. Pretty simple. If we have y equals negative x squared, it reflects over the x-axis. Now, we only talk about reflections from north to south or over the x-axis because the squared term makes it positive, so we can't reflect over the y-axis here and here because we just reflect upon ourselves. Okay? Now, let's do a recall of the locus definition of a line in a circle, right? The locus definition of a line are all points in a plane that are equidistant from 2 points, right? If you have 2 points, a line is something that can go through those 2 points all the way across a plane. And a circle is all points in a plane that are equidistant from the center. Now, what we've been doing before is the locus definition to find the equation of a line that is equidistant from 2 points, okay? The locus definition is when you use the distance formula. Okay, I know a lot of people have been confusing that. Now, let's talk about the locus definition of a parabola. It is all points equidistant from a given point in a given line. That given point is called a focus, and the given line is called the directrix. Okay, it's all points that are equidistant from those 2 places. So, if we look here, okay, this is if we have a positive p. We have this point here. This is our focus, and this is our directrix. Okay, now if we were to pick this point here, the distance here from the focus to the parabola is the same distance as it would be here from the directrix to the parabola. That's why it is the locus definition, because those are the same. So, the equation that we're using for the parabola is y equals 1/4px squared. If p is positive, we have an upward facing parabola, and if p is negative, we have a downward facing parabola. Our focus is 0p, and our directrix is y equals negative p. It's really important you have the y equals. You can't just say my directrix is negative p. It's a line. The directrix is a line, so it has to be y equals. Okay? So if a parabola has a vertex of 0, 0, which is our standard parabola, a focus of 0p, and a directrix of y equals negative p, this is the equation we use. Y equals 1/4px squared. This is the baseline parabola. Now before we talked about our standard was y equals x squared. Okay? This was, right, we have this value here, 1/4p, just equaled 1. Okay, our coefficient was just a positive 1. So, let's do an example. Find the coordinates of the focus and the equation of the directrix for the given parabola y equals 3/7x squared. Okay, so the 3/7 is our 1/4p, and I'm going to solve that for p. So I cross multiply, so 7 equals 12p, so p is 7/12. P is positive, so I have an upward facing parabola. And I know, excuse me, my focus is 0, p. So my focus is 0, 7/12. And my directrix is y equals negative p. So my directrix is y equals negative 7/12. I want you to label it like this. Focus here, directrix here. You don't have to put the 0p and the y equals negative p, but I do want you to label it like that. Let's do another example. Find the equation of a parabola whose vertex is at the origin. So that means my vertex is 0, 0. So my equation will be y equals 1 over 4p x squared. And my focus is 0, negative 5 over 3, which means p is negative 5 over 3. So my equation, I have y equals 1 over 4 times negative 5 over 3 x squared. So I need to simplify, so y is 1 over negative 20 over 3 x squared. So y is negative 3 over 20 x squared. Okay, so these are parabolas that have a vertex at 0, 0. Not much has happened to them. Let's do some more. Translated parabolas. So the parent equation that we have, y equals ax squared. Now a is the 1 over 4p. Okay. A translated parabola is y equals a times x minus h squared plus k. Guess where we get this from? Completing the square. It all comes back to completing the square. Isn't that just so dandy? Okay. Now, what this means is I am translated x units horizontally because it's inside of the parentheses and k units vertically. So here's what my graph would look like. If I was translated up, I would have my new focus. My new focus is h, comma, k plus p. Now what the h is my vertex. My vertex is h, comma, k, kind of like when we did a circle, right? It's all related back to that. So my vertex is h, comma, k. My focus is h, k plus p. My axis of symmetry, that's this line right down the middle that if I was to fold my parabola on that line, it would fold exactly on top of itself. My axis of symmetry is x equals h, and my directrix is y equals k minus p. This is the equation of a line. Y equals 1 over 4p times x minus h squared plus k. Your book does this. Y minus k equals 1 over 4p times x minus h squared. I don't want that. That's wrong. You need to write it like this with the k on the same side. All right, so let's do an example. A parabola has vertex negative 2, 1, focus negative 2, negative 1. I wrote focus twice. Ha! And focus negative 2, negative 1. You don't need to write it twice. I don't know why I did that. I want to find the equation of my parabola, my directrix, my axis of symmetry, and I want to sketch the parabola. Okay, so I know that my vertex is h, comma, k. And my focus is h, comma, k plus p. Okay, I can automatically find my axis of symmetry. It is x equals h, which is negative 2. Right, this is x equals h. It has to be an x equals. You cannot say my axis of symmetry is negative 2. You have to write x equals negative 2. So now my focus, I have negative 1 equals k plus p. And I know that my k is 1, so negative 1 equals 1 plus p. So p is negative 2. So my equation is y equals 1 over 4p times x minus h squared plus k. So y equals, my p is negative 2, so I have 1 over 4 times negative 2, which is negative 8, times x minus a negative 2 squared plus 1. That's the equation of my line. Now I go to graph it. These are the things that you need to label on your graph. You need to label your vertex, so we have negative 2, 1. Your focus, negative 2, negative 1. Your axis of symmetry, which goes through both of those. And your directrix, which I need to find my equation for. Your directrix is y equals k minus p. So we will have y equals k is 1 minus a negative 2. So my directrix is y equals 3. And you will draw it like this. Okay? Now we're just sketching, but what we need to do is we need to find another point. So I'm going to plug in 0 here for x So I get y is negative 1 over 8 times 0 plus 2 squared plus 1. Okay, to get my next value, which would be y equals negative 4 over 8 plus 1, which negative 4 over 8 is negative 1/2 plus 1, which is 1/2. So that means I go through 1/2 here, and 2 away, I go through the same amount. Hopefully you remember some of this from Algebra 2. But we know that the axis of symmetry means I have this same point reflected across the axis of symmetry. It's the same distance away from this line. All right, let's do another example. So my vertex is 3, negative 5, which I know is HK. My focus is 3, 5, which I know is HK plus P. So write the equation for parabola, directrix, axis of symmetry, sketch, all the things. Okay, so I first want to find my P, right? P is question mark. I know that 5 in my focus equals K, which is negative 5 plus P. So P is 10. So my equation, I'll have y equals 1 over 4 times P, x minus h squared plus k. 1 over 40 times x minus 3 squared minus 5. My directrix is y equals k minus p, so I'll have y equals negative 5 minus 10, so y equals negative 15. So on my graph, I'm going to say this is negative 15. My focus, I have 3, 5, and my vertex is 3, negative 5. I have an upward facing parabola. I need to find another point, so I plug in 0 for x to get my y-intercept. So I'll have y equals 1 over 40 times 0 minus 3 squared minus 5. So I will have y equals, this will give me 9 over 40 minus, what am I, want to get to 5? Okay, so 9 over 40 minus 5, right? That will be my, y-intercept. It gives me about, let me see, well, it's about negative 4.78, which puts me about here. Here's my axis of symmetry, which I did not write for you. My axis of symmetry is x equals h. And I have that point, 1, 2, 3. That point. It's a very wide parabola. Okay? So, these are all the things with parabolas so far. Okay, finding equations, you do need to know how to do all that. Now let's talk about applications. Because guess what? Applications actually have some use. Parabolas are important. So we have what's called a parabolic reflector. It kind of looks something like this, where light comes into here and it's reflected off. Okay, it happens for a lot of different things. Parabolas actually can be used a lot in sound reverberation as well, if you are curious about that. Let's do an example with it. Example 5. The reflecting surface of a parabolic antenna has the shape formed when the parabola below is rotated about its axis of symmetry. If the measurements are in feet, how far from the vertex should the receiver be if it is placed at the focus? Okay, that's the key there, is we're placing it at our focus. So we need to find our focus. So we have this equation, and I know that 1 over 20 is 1 over 4p, okay, which tells me that p is 5. Now, my vertex is 0, 0, which means my focus is 0p. So I'm placing the receiver at 0, 5, Now my measurements are in feet, so the receiver should be 5 feet away from the vertex. And that's all. I just needed to know how to solve for my focus and solve for P. All right, we will do plenty of practice later on with parabolas. Make sure you know the equation of the line, the focus, directrix, axis of symmetry, vertex, all the things. Okay, with that,